EYERECKON is the project name that encompasses our video analytic research here at LAS. The core goal of this project is to develop techniques and visualizations to help analysts rapidly triage video data. Put simply, we want to make video content searchable, no matter how small or underrepresented the item or action of interest is within a dataset. Given the needs of our original customers back in 2019, we produced a prototype user interface to help with refining and prioritizing our customers' dataset. Along this journey, we realized that this decomposable application would be a great place to centralize our outcomes from LAS video analytic research. It's given us first-hand experience on how to combine video analytics for a richer user experience. Specifically, this year, most of our goals have been inspired from previous interactions with this UI prototype. Our first goal this year was to reduce the label burden for an analyst. This year we focused on optimizing our labeling task. Our team built methods to sample and summarize our data so that we can ensure diversity of labels across the corpus. In addition, we further optimized our workflow by pre-running off-the-shelf models to help reduce the number of actions required by an analyst for each labeling task. Next year, we want to focus a little more on how to combine these steps to provide an analyst detailed feedback on why their specific labels mattered. But what if we didn't have to get an analyst a label at all? What if we could just pass an algorithm some data and it automatically determines how to recognize the objects? That's what some of our research focuses on with Fayetteville State University. Through 3D modeling and generative adversarial networks techniques, we are building out a workflow to test and evaluate how well this process works on mission-related data. Our second goal was to move the needle closer to sense-making. We wanted to improve our processing framework so that we could create richer user interface features. Fundamentally, this meant that we needed a way to chain together machine learning model output to get the desired results. For example, one of the analyst questions we wanted to make headway toward this year was, what has changed in this area since the last time I visited? Although simple to ask, when we went to answer this question programmatically, we realized how far down the rabbit hole we had to delve. Just as a disclaimer, we aren't finished with this research, but while we make progress, we are also trying to embed easier options for an analyst to access each particular section of information. So the first section is, how do we identify the same area? For us, our data included GPS coordinates, so we could simply extract the geos from the video. Some of our data didn't include geographic information at all, so further research may be needed to match those videos. How do we identify the same direction? Well, we found a field of view detector that leverages video content and overhead imagery, but it hadn't been trained on the same domain of data, so again, further research was needed. To simplify our assumptions for our data set, we found that we had 3 different views: a front-facing view, a left-facing view, and a right-facing view. With the help of performer guidance, we were able to narrow down our video footage directionality. For the third step, we wanted to identify specific objects. Well, with the off-the-shelf object detectors like YOLO, we were able to identify large objects of interest within the frame, but it performed poorly when it came to smaller objects. Another performer, SAS, is helping us to figure out ways to get a better model for these smaller objects. Once we have the smaller objects, though, how do we identify the same objects? Well, within a video, we have evaluated object trackers for large objects. Theoretically, with a great object tracker, you can link all of the detections across the same video together into one unique object. Unfortunately, we haven't found an off-the-shelf solution yet. It wasn't robust enough for specific use cases to perform at scale. Given our current resources, we are evaluating what modifications we can do to improve this object tracking. And at the very end, how do we actually identify the analyst right change to tell them? Given our previous experience with object tracking, we haven't delved too far into an automated solution for this. But for the current time, we are creating specific content filters based on color and type for vehicles and people. Our third goal is expanding video analytics to the masses. For this year, we wanted to showcase our research outcomes outside of this UI prototype. We wanted to ensure that our processes for this prototype are repeatable and transferable to new domains. Given this goal, we partnered with AWS ProServe to envision a machine learning pipeline that leverages both low and high side data to compute and augment off-the-shelf models for better performance on intelligence community datasets. In addition, they're also focusing on machine learning operations, specifically things like creating metrics to ensure data and models are kept healthier after deployment. If 3 goals weren't enough, our last goal focuses on preparing for the future. Some of our performers are looking at new types of cameras and their corresponding formats to ensure that our machine learning research can be transferred and optimized appropriately. Others are looking at how to efficiently train medium-scale video models via things like parameter-efficient tuning. So with that, be sure to stop by and see if you can find some of these objects within our app.